Alright, in this video we're going to learn how to balance each redox reaction in an acidic solution using the half reaction method. To do this, you're going to start by separating out the reactions into their half reactions. So we'll start off with hydrogen peroxide, which is H2O2, and that is actually going to be changing over to O2. This is happening in an acidic solution, and one of the things that defines an acid is its ability to donate positives or protons to a solution. In this case, our positives are going to be our hydrogens. Our first step is going to be to balance out our oxygens, and in this case we have 2 on the left side and 2 on the right side, so that's done. The next step will be to balance out our hydrogens using those hydrogen ions. So we have 2 hydrogens on the left side, and now we have 2 H plus ions on the right side. Our equation is looking more balanced. The last step is to balance out the charges, and this is very similar to what we've done before. And to balance out the charges, on the left side there's no charge. On the right side there's currently a charge of +2. We need the product side and the reactant side to be equal, so both will need to be equal to 0. To do that, we're going to add 2 electrons to the product side, and that balances out our first reaction. Our next step is to balance out the second half reaction. So we have the dichromate ion floating around in solution, and that turns into a chromium 3 ion. Again, our first step is to balance out the non-oxygens, non-hydrogens. In this case, it's going to be the chromiums on the product or reactant side, It has 2 chromiums. On the product side, there's only 1, so we'll balance out the product side by adding a 2 in front of our chromium ion. The next step is to balance out our oxygens. Now, we didn't have to do this in the first half reaction, but we'll have to do it now. In order to balance out our oxygens, we're going to add water molecules, since in acidic solutions there'll be lots of water. So we have 7 oxygens on the left side, which means that we're going to need 7 water molecules on the product side. What we've essentially just done is we balanced out the oxygens, but now we've unbalanced something else. We've introduced hydrogen. Again, this is in an acidic solution. So now we have 14 hydrogens on the product side. We need to add 14 hydrogen ions to the reactant side. So we're just going to go 14 H plus. And now all of our elements should be balanced. The last thing to do is to balance out the charge. On the reactant side, we have 14 positives and 2 negatives for an overall total of 12 positives. On our product side, we have 2 times 3 positives, so we have a total of 6 positives on the product side. So again, we had 12 positives on the reactant side and 6 positives on the product side. We need to get those to balance out. To get them to balance out, just like we did in the first one, we're going to need to add electrons to the side that's the most positive. So we're going to add electrons to our reactant side, which is actually good because our electrons, when we add these 2 equations together, can't be on the same side in order for them to cancel out. So we're going to add 6 electrons total to our reactant side, and that's going to bring this number down to a +6. And so we should be good to move on to our last step. Before we can combine the equations together, we need to make sure that our electron numbers are the same, and as they currently are not, we're going to multiply this top equation by a factor of 3 so that our electron numbers will be the same. So I went ahead and multiplied that top equation by 3 and came up with what you see on the bottom. And now I'm ready to add those equations together. Again, as we've talked about in class, if the electrons appear on opposite sides of the equation, you subtract them out. So there's 6 electrons on the reactant side and 6 electrons on the product side. So those cancel out, which was essentially the reason why we multiplied by 3 on the top equation in the first place. We have to check to make sure nothing else will cancel out. So if we're checking out our hydrogen ions do appear on both sides of the equation. Therefore, on the product side, the 6 hydrogen ions are going to cancel out, and 6 of our hydrogen ions will cancel out on our reactant side. 14 minus 6 will be 8. So 8 hydrogen ions is what we will have left over to write in our final equation. There's nothing else that looks like it will cancel, and so we can proceed on with our last step. Our last step is to write out the equation with its symbols and coefficients. I'm going to do that now and pause the video. Alright, so the equation, once we put everything with its symbols, should be as follows. It doesn't really matter what order you put your reactants and your products in, as long as you make sure you include everything. Your last and final step is going to be to make sure that everything is still balanced and your charges are balanced as well. So I'm going to start off with my hydrogens. I have 8 hydrogens on the reactant side, plus an additional 6 for a total of 14 hydrogens. On my product side, I have 7 times 2, so 14 hydrogens. My hydrogens are balanced. Chromium, I have 2 chromiums on the reactant side and 2 on the product side. Now, it's important to note that it doesn't matter if you have chromium looking like it's just an atom or if it's the ion, it still is chromium. The last thing I need to balance then is, or double check, is to make sure that my oxygens are still balanced. I'm going to do this in 2 parts. I have 7 oxygens on this side and I have 7 for my water. I have 3 times 2, so I have 6 oxygens from my hydrogen peroxide, and I have 6 oxygens in my oxygen gas. So all of my elements balance out. That's kind of a big relief after doing a longer product or a longer equation like this one. The last thing I'm going to do is I'm going to check my charges, make sure that my charges balance out on the left and right. If they didn't, I'd have to go back and figure out what I had done wrong in an earlier step. So 2 times 3 positives gives me a total of 6 positives. I have 8 positives on this side plus 2 negatives. 8 minus 2 will give me 6 positives. So I'm pretty confident that this would be the right answer for our initial reduction reaction. H2O2 liquid plus the dichromate ion gives you or yields oxygen gas plus the chromium 3 ion. So to review the steps for balancing reactions in acidic solution, what we did first was we separated out each half reaction, and for each half reaction we balanced out the non-hydrogen and oxygen atoms first. The next step was to balance out the oxygen atoms by adding water molecules to the side that needed more oxygen. In some cases you don't have to do this because there are no oxygen atoms in your half reaction. In that case, you can skip to balancing out the hydrogen by just adding the hydrogen ions to the side that needs more hydrogen. If you added water, then you automatically have to balance out your newly added hydrogen atoms that you got from adding water by adding hydrogen ions to the side that needs the additional hydrogen. You then balance out the charges of each side of the reaction by adding electrons to the more positive side, and repeat this process for the second half reaction. Once both half reactions are balanced, you then compare and you make sure that the total number of electrons in each half reaction are equal. If they are not, you want to find a common multiple and multiply out each equation as necessary. If you're lucky, you won't have to do this, and if you do have to multiply, it's nice when you only have to multiply one of the equations. In some cases, you have to multiply out both equations, and again, just a reminder, like we've talked about in class, make sure you go back at that point and double check that all of your atoms are still balanced and that your charges are still balancing on both sides of your equation. The last thing that you're going to do is to combine the 2 equations together, and note that ions or molecules that are the same and on the same side are then added together, and ions or molecules that are on opposite sides are subtracted out. Your electrons should automatically cancel out because that's what you were working on in step 7. Making those electron numbers equal, and they're on the opposite sides of the equation, so they should cancel out. Oftentimes waters will cancel out, at least some of them, and the hydrogen ions. So generally you're left with less hydrogen ions and less water molecules than you started off with when you have those on both sides of your equation.